Let's learn about the most plausible Lewis structure. At the end of this lesson, students should be able to explain the exceptions to the octet rule, incomplete octet, expanded octet, and odd number electrons. Which is the Lewis structure of CO2? Do you get the answer? Don't worry, you will learn how to determine the most plausible Lewis structure in this lesson. Certain molecules are possible to have more than one Lewis structure. However, the most stable structure is used to represent the molecule which is referred to as the most plausible Lewis structure. One way to determine the most plausible Lewis structure is based on the concept of formal charge. Exceptions to octet rule. There are three categories characterized by incomplete octet, expanded octet, and odd number electrons. Incomplete octet. Incomplete octet occurs when the central atom has fewer than 8 electrons in its valence shell. Elements in group 2 and 13 in period 2 with low metallic properties do not donate but share the electrons. Metals like beryllium and aluminium and metalloid boron exhibit covalent character when they combine with nonmetals. Beryllium, boron, and aluminium cannot achieve octet configuration even after sharing electrons with other atoms.
Hi, this is Dr. B. Let's do the Lewis structure for BeH2. On the periodic table, beryllium has 2 valence electrons, and hydrogen has 1, but we have 2 hydrogens, so we have a total of 4 valence electrons. Put beryllium here, and hydrogen will go on the outside. So we've got 4 valence electrons. We'll put 2 between atoms to form chemical bonds, 2, 4. And actually, we've used all our valence electrons at this point. Let's check and see if we have full outer shells. Hydrogen only needs 2, so both of those hydrogens are fine. And beryllium has 4, but beryllium's an exception. It doesn't necessarily need 8 valence electrons. So with that, we've done the Lewis structure for BeH2. This is Dr. B, and thanks for watching.
Look at beryllium hydride structure. Both hydrogen atoms have duplet, but beryllium only has 4 electrons around it. Beryllium is incomplete octet. Is it this structure is a possible Lewis structure? To get the answer, let's calculate the formal charge of its structure. Beryllium has formal charge 0. Hydrogen also got 0. Therefore, this structure is the most plausible Lewis structure because formal charges on all atoms are 0. Expanded octet. Expanded octet occurs when the central atom has more than 8 electrons in its valence shell. Expanded octet usually involve non-metal atoms of third period and beyond, which have empty 3D subshell. Here is the example of expanded octet. Look at sulfur hexafluoride. All fluorine atoms have completed octet, but sulfur has 12 electrons around it. Sulfur has expanded octet. Is it this Lewis structure is a possible structure? To get the answer, let's calculate its formal charge. Formal charge of sulfur is equals to 0. Also for fluorine atoms. Therefore, this is the most plausible Lewis structure because formal charges on all atoms are 0.
Hi, this is Dr. B. Let's do the PCl5 Lewis structure. Phosphorus on the periodic table, group 5, 5 valence electrons. Chlorine, group 7, 7 valence electrons. But we have 5 of those, so we need to multiply that times 5 for a total of 5 plus 35, 40 valence electrons. We'll put the phosphorus in the center, and then along the outside, we'll put the chlorines. So we have 5, and there they are. We'll draw a line between each phosphorus and chlorine, which will represent a chemical bond. So that's a pair of valence electrons there. So we have 1, 2, 3, 4, 5. We've used 10 valence electrons. Now we'll go around the outer atoms and put valence electrons on those until we use the rest up. So we have 10, 12, 14, and 40. At this point, we've used all of the valence electrons. All of the chlorines, they're symmetrical, and they have 2, 4, 6, plus this line right here, 8 valence electrons. So all the chlorines have octets. The phosphorus in the center actually has 10 valence electrons, but that's okay. Phosphorus is in period 3 or row 3 of the periodic table, and those elements and the ones below them can have more than 8 valence electrons. So we've used all of our valence electrons, all 40. We've got the structure here. We could check our formal charges if we wanted to make sure. If we did, we'd find they were all 0. So this is the Lewis structure for PCl5, and this is Dr. B. Thanks for watching.
Odd number electrons. Some molecules have odd number of valence electrons. Most odd electron molecules have a central atom from an odd number group, such as nitrogen in group 15 and chlorine in group 17. Here is the example of odd number electrons. Look at nitric oxide structure. There is unpaired electron on nitrogen atom, so the molecule has odd number electron.
This is the NO2 Lewis structure. For NO2, we have 5 valence electrons with the nitrogen, plus 6 for the oxygen. We have 2 oxygens. So 5 plus 12 equals 17 valence electrons. Nitrogen is the least electronegative, so we'll put that in the center, and let's put an oxygen on either side. We have 17 total valence electrons for NO2. We'll put 2 between atoms to form a chemical bond. Let's go around the oxygens, form octets. So we have 2, 4, 6, 8, 10, 12, 14, 16, and we have one more. We'll just put it right here. At this point, we've used all 17 valence electrons. This oxygen right here has 8, and this oxygen here has 8. So the octets are fulfilled for the oxygens. For the nitrogen, however, we only have 5 valence electrons. We can take these 2 valence electrons here and move them between the nitrogen and the oxygen to form a double bond. And now we still have 8 on this oxygen here. And for the nitrogen, we have 7. For the NO2 Lewis structure, that's the closest we're going to get to having an octet for the nitrogen atom. So this is the Lewis structure for NO2, and this is Dr. B. Thanks for watching.